Good morning all. Today I am going to talk a topic on immunology, ELISA. So, what is ELISA? ELISA is nothing but enzymic immunosorbent assay. Why it is named as ELISA, enzyme-linked immunosorbent assay, from the name itself, which is immuno, which means here we use antigen or antibody to find the concentration, which is an immuno component, antigen or antibody interaction, and sorbent. Sorbent is nothing but a plastic plate where we put antigen or antibody, and enzyme link, which means here we use enzyme to attach with antigen or antibody. So that's why which is named as enzyme linked immunosorbent assay. So why we are going for enzyme linked immunosorbent assay? So which is a fast and a rapid diagnostic test. Commonly used to find concentration of an analyte. So, what is analyte here? Here the analyte may be antigen, antibody, vitamins or hormones. Not only this, the thing which is what we need to find the concentration can be diagnosed using ELISA. So next we will see what is principle behind the ELISA. So what is principle behind ELISA? So first it is mainly used to find the concentration of antigen or antibody. So in this method, we will code the antigen or antibody in the microtiter voltage so to which we will add a primary antibody to interact with the antigen. To this, we will add enzyme linked secondary antibody. So, to find the concentration of an antigen or antibody, we will add a substrate to react with the enzyme. Which shows the color change. From the color change, we can quantify or we can diagnose whether there is a presence of an antigen or antibody. So these are the principle behind the ELISA. So next we will see what are the materials we require for the ELISA. So what are the materials we need for ELISA? First, we need microtiter voltage. So microtiter plate usually we use 96 voltage. So why we are using this? Which has the capacity to absorb the antigen or antibody on the surface. Then we will use blocking buffer. So why we are using blocking buffer? So blocking buffer which blocks the antigen to react with a certain protein. So then we need antibody. Antibody which is linked with enzyme. And we need wash buffer. So what is the purpose of wash buffer? Which will wash away the unbound antigen or unbound protein. So then we will add substrate. So what is the purpose of the substrate? This substrate will react with the enzyme which is attached to the antibody, and this will show the color change. And also we need spectrophotometer to quantify or to diagnose what is present in the sample. To find the concentration, we need of a spectrophotometer to analyze the concentration of an antigen or an antibody. So now we will see what are the procedure in the ELISA. What is the common procedure we will follow to perform the ELISA. So what is the procedure of ELISA? First, we will coat antigen in the microtiter plate. So after coating the antigen, then we have to wash with wash buffer to remove the unbounded antigen. So then we will add antibody which is linked with an enzyme. So this enzyme linked antibody will react with the antigen to perform the reaction. So then we have to again wash this with wash buffer to remove the unbound antibody to remove from the sample. So then we have to add the substrate. So this substrate will react with the enzyme which is attached to the antibody. Then it will show the color change in the well plate. So after this also we have to wash with the wash buffer to remove the unbound substrate from the well plate. So then after this we will quantify the antigen or antibody in the well to find the concentration using the spectrophotometer. So next we will see what are the types of ELISA. So there is basically 4 types of ELISA which we perform. So what are the types of ELISA? 1. Direct ELISA and indirect ELISA, sandwich ELISA and competitive ELISA. Competitive ELISA. So this all types of ELISA will follow the same principle in the ELISA, but what it differs, the number of antibodies we are using and series of reaction will be changed. Let me explain from the simple diagram. So what we will perform in a direct ELISA? We will coat an antigen in the microtiter plate. Then we will add a primary antibody which is linked with the enzyme. So to this we will add a substrate. This substrate will react with enzyme and it will show the color change. So this is direct ELISA. In direct ELISA we will coat an antigen in the well. To that we will add one primary antibody which is linked with the enzyme. So that will react with the substrate, shows the color change. So what will happen in case of indirect ELISA? So indirect ELISA we will coat the plate with the antigen. To the antigen we will add an antibody, primary antibody which is not linked with the enzyme. For this primary antibody we will add a secondary antibody. This secondary antibody is linked with the enzyme. So then we will add a substrate to react with this enzyme. So this substrate reacts with the enzyme and it shows the color change. So this is what we call it as an indirect ELISA. Indirect ELISA, the enzyme will tag with the secondary antibody, not with the primary antibody. That's why it is called as an indirect ELISA. So then what is sandwich ELISA? So sandwich ELISA, we have the role of capture antibody. So what is the capture antibody? This capture antibody will hold the antigen to the has the antigen. So to this antigen we will add a primary antibody which is not linked with the enzyme. So in sandwich ELISA, this primary antibody we may attach with the enzyme. So to this the substrate will be added. The substrate will show the color change. So this looks like a sandwich. The antibody, capture antibody, then antigen, then the primary antibody which is linked with the enzyme. To that we will add a substrate which shows the color change. That's why it's called as a sandwich ELISA. When we talk about indirect ELISA, there is two type of indirect ELISA. One is direct and indirect sandwich. In sandwich ELISA, there is two type of ELISA. One is direct ELISA, direct sandwich ELISA. Another one is indirect sandwich ELISA. To primary antibody, we are adding a substrate which shows the color change. We call it as a direct sandwich ELISA. The same way, we add capture antibody. To that we will add antigen. To that we will add primary antibody, but which is not attached to the enzyme. When again we are adding a secondary antibody which has an enzyme link, to this we will add a substrate. This substrate will shows the color change. So this we call it as an indirect sandwich ELISA. To this, that is the role of a two antibody, primary antibody and secondary antibody. To the you never link enzyme with the primary antibody, only with the secondary antibody. That's why it is called as an indirect sandwich ELISA. Inside direct sandwich ELISA, we directly add enzyme, we link enzyme with the primary antibody. So then we will go for a competitive ELISA. What is competitive ELISA? To the microtiter well plate, we will add an antigen. To the antigen, we will add two antibodies. One is enzyme linked antibody and also enzyme not linked antibody. So this enzyme linked antibody and enzyme not linked antibody will compete for the site in the antigen. So then at the result, it will when antigen react with the enzyme linked antibody, and if antigen attached to the enzyme not linked antibody, then we add a substrate to the both. So only when enzyme linked antibody react with the antigen, it shows the result, not the antigen which is not linked with the antibody will not show the color change. From this we can identify whether this antigen is common for that antibody or not. So in this case, both the enzyme linked antibody and enzyme not linked antibody will compete the size for the antigen to show the color change. So that is what is called as a competitive ELISA. So that's all about enzyme linked immunosorbent assay. We talk about advantages. Direct ELISA will have more advantages, but it also have a disadvantages, like it will have a fight for a site in an antigen. When we talk about indirect ELISA, the secondary antibody will have a cross link with the antigen to shows the negative result. So usually direct ELISA and indirect ELISA, each ELISA will be used. It's a fast and effective method to find the concentration of an antigen and